that's not generative AI use case in general. Like all the heavy lifting is going to be done by classical statistics, by classical machine learning. And that's basically all the magic like behind the machine learning. It doesn't matter, is it GPT or is it like something from before? That's basically what is happening.
The intention with this, Vitalijus, is really to break down and simplify machine learning for some executives out there who have to make really tough decisions about what they're going to do, what they're not going to do. And machine learning is not the attractive, hot topic that everyone's talking about on LinkedIn. So as a starting point, can you kind of clarify for me what machine learning actually is versus some of the things I might be hearing about on the news every day?
We don't talk too frequently about machine learning because a lot of people don't understand what this really is. So right now you can hear about AI, generative AI, LLMs like ChatGPT, but all of these are just like a small subfields of a machine learning, like the things which have been here like for tens and tens of years. So it didn't just arrive with ChatGPT a few years ago. We had it before. It just wasn't like so popular. If we would be talking about machine learning in general, this is basically techniques to drag patterns from data and to make the predictions. This is like the basic definition, so that you would have a system where you don't have to program all the rules manually, but which learns from some specific subset. Doesn't matter, is it audio, is it text, is it voice, is it like something else, and then the system tries to learn the correspondence between the points and does the prediction. And that's basically the machine learning.
What about, so what I enjoy with working with Vitalijus is the combination of using generative AI with machine learning. So as generative AI came out, Vitalijus, I know there's a lot of projects we work on. Like one of my favorites that you have helped with, I don't think you were on the project, but is writing SQL code using generative AI into a database that is helping with predictions. Can you explain how that works and the combination of that why that is such a huge movement that we're going to see over and over again for our proposals?
Absolutely. So this this specific project, it's very interesting because like if we would be talking about generative AI, it's not a solution to a lot of problems, but very frequently it is an interface to other subsystems. And this use case was exactly that. That's generative AI models. They are responsible for writing the code because a lot of code is repeated. A lot of code, especially in SQL, which is here like for many years, it was pre-trained on that. And what it does, it gives you like it spits the code. It takes as an input the natural language, and as an output, it gives you the command, which is supposed to give you the result that you want to, and that goes into another subsystem.
And then what I pitch on sales calls is I always think of that example of how can you take a deterministic system, which is the code that we've been developing for the last 20 years, and putting it into SQL databases. How can you be sure that the AI always uses deterministic results? Because a generative AI is stochastic. It's guessing at the next word, so it's not going to give you the same answer. So why is that so advantageous when somebody is just using ChatGPT off the shelf?
Oh, that's a very good question, and that's why the topic of security and guardrails, like in particular, are getting like more and more often right now. Especially like with the vibe coding, that's basically the problem, because the systems have been pre-trained on millions of lines of code of various level of quality. So of course it doesn't adhere like to good practices. And like when you fully rely on these kind of coding, you can't be sure that like it's good enough. That's why there is always some layer before the production and what the LLM is outputting. This is what we've been doing like on all of our projects. It doesn't matter, is it giving a comment, is it giving like a Python code or an SQL? You always have like a moderation level, which makes sure that it's not gonna break the things. A lot of people have seen like in initial chatbots. I'm not sure it was with Amazon, but like where you're asking a support chatbot like what's in the root directory, it gives you all the output, or you just ask to remove like to delete the operating system, and it was literally doing that. And that's what happens like when you don't give enough guardrails. So like it's was, you know, like in Spider-Man, with great power comes great responsibility, and that's basically what's happening like with LLMs. You know, like they're they're very flexible, but that's the risk where like which comes with it.
Interesting. You mentioned this layer. You said there's a layer between. Can you talk about that layer again? I didn't want to skip over that.
Hmm. So in this specific use case, if you're using an LLM like some generative AI model to write SQL code for you, um, before it goes actually to your database, you have a preset of rules where you sanitize, where you make sure that it didn't give some, I don't know, dropping database queries. It's not requesting too many resources that you don't want to, but all of those are manually created rules according to your business, and that's very important to have because with uncontrolled input to the system, any user could ask to drop the database to access sensitive fields that they are not supposed to be having, or what can be even. But the tricky part is that these kinds you can notice. But for example, imagine if someone would alter the data inside of database, and that would influence like another users. This is like way harder to notice, and that's why you need these kind of processes like before going to production.
And that I get asked a lot, Nishan, a lot is we've been like a company will come to us, let's say it's a $10 million company or $100 million company, it doesn't matter. And they're like, we've been using ChatGPT and it's not working. It's not providing the same response all the time to help our business move forward. We need to add something to it. We don't know what it is, but we need to add something to it to get it to behave in a better way. And I think what Vitalijus is talking about is that is the behavior that an agency like us can provide that gives the ability for the machine to give responses back on the data that the company harnessed over time. So it's almost like this pile of data becomes so valuable, they can't access it with just ChatGPT because it's not going to give you the answer that you're looking for. It's going to rank it in the wrong order, and some document's going to be shared with the wrong user, or some invoice will be shared with an engineer, right? It's the rule-based coding that Vitalijus does in this team determines the safety of the model, but also it's an engineering job. It's not a ChatGPT AI vibe coding job. It is truly an engineering job.
Interesting. I want to know because we've thrown around a few words, LLMs, Gen AI, and then we've also talked about this rule creation that's manual. So first, keeping with this rule creation, you said Vitalijus does. So is this something an ML engineer would do, is create this? And where does that separate from what a typical software engineer would do? Full stack, let's say a full stack engineer.
So depending like on the business case, but that's usually what machine learning people do because we are responsible for interactions with the data, so we know what the regular use case is, so we know where to put the limits. But this is pure coding, so just Python rules or like whatever language you're writing in. This is software engineering, but just like in domain of data.
Hmm. Okay. And where does the software engineer end and the machine learning engineer begin?
That's a tricky question. That's a really tricky question, especially like in the last few years. I would say like the borders are getting really thinner, and right now you can see like a lot of positions of software engineering and machine learning domain, and machine learning engineers who are like a lot of like heavily involved in software engineering. I would say there is a strong transition of machine learning in the last, especially like 5 years, because we're getting from the research phase where like we didn't have machine learnings, we had data scientists, like people who were doing some deep tech, but like the end project was just like a presentation to the stakeholders, but it never went to production. It was not according to any software engineering practices. What we have right now is that AI machine learning went into the production grade, and now like we're getting more and more integrations in different businesses. And that's why, for example, right now, in order to be machine learning, it's not enough to understand how neural networks are working, but you need to know how to build pipelines. You need to know how to create microservices, how things are evolving. If you are not in some very, very niche domain, if you work on some, I don't know, optimization techniques like deep tech in some very, very specific domain, like usually right now, it's way more full stack than it was before.
Interesting. So it sounds like it's a little bit easier for someone who's a machine learning engineer to understand the full stack side of things and support than someone to like, oh, I'm just going to pick up machine learning as a side hustle thing.
we have one of our really good engineers that's been with us since 2014. Very, very smart engineer. He came to us one day and we're like, hey, you should learn machine learning. Like, we should add that to our stack. And after meeting Vitalijus and Jurgis and some of these guys have been working on this for 10 years of their lives, right? Even, I don't know how long you've been doing this, Vitalijus.
8
8
years.
years? Yeah. So he's been doing it for 8 years. And this engineer came back to us and he's like, they're really smart. Like, this is really hard. Like, this is not something I can just pick up. Like, we should hire for this. So yeah, even the best full stack engineers look at machine learning and like it's a craft, right? It's like asking a basketball player to go play baseball. Like, it's a different skill set.
Yeah, and I think what's interesting to me from a business perspective and hiring is that machine learning, I might not want to bring someone full time onto my staff for machine learning. So kind of talk to me about that. So now I understand what machine learning is compared to Gen AI and this prediction and things like this. How do I know if my project will need machine learning?
From a business sense, it's when they talk about the back end and the predictive analysis of what they need to do for a business, like anomaly detection, trying to forecast, trying to understand from purchase history what products can be presented. But Vitalijus, what is the best examples? What do you think?
I think like there is a concept of data maturity. So there is a concept of data maturity that every company is at some specific level of data maturity. So like on the first level, it's when you have data unstructured across like various sources of information. And as you go up, when you're already going to databases, to data lakes, where you start getting insights from your data, if you're at that level, that's where you can introduce machine learning. That's the level where you can not only bring analytics from before, but you can actually predict some future outcomes. So that's a very strong point, and we have like a lot of use cases. Even like when clients are coming to us, they want to build something fancy from machine learning, but if you don't have proper data, like you can't do that. Like data is the king. Like without like data quality is like the most important thing. If you would compare the solution, you can take the most fancy machine learning, like deep tech, like whatever. If your data is bad, like there is nothing you can do about it.
Mm.
Let me ask you, Vitalijus. So let's just paint a picture, right? Client has we did Symbiotica's product suite, right, and did prediction analysis based on that. But let's use that example. So product company selling e-commerce stuff, whether they're drop shipping, doesn't matter, sneakers, dietary supplements, doesn't matter. But they have 5 years of data in their database of all this purchases that have happened for demographics of people, cohorts. My prediction and my analysis that I talk about on stage a lot is that the movement that Gen AI has brought to e-commerce is that we're selling to an individual level going forward. We're no longer selling to cohorts because we can actually trace an individual person's track record through a product history and then determine if that person matches another person or how to advertise to that single person in the future when they look like another person in your history. Machine learning enables that ability for us to do the analysis. Gen AI enables us the natural language to have a non-coder ask the question of, this product I would like to push off my shelf, who in the database can help? But from an engineering standpoint and from a predictive analysis standpoint, how do you look at that business and say, you need machine learning, you need Gen AI, you need full stack? Like, where is that map of a Venn diagram fall when we propose that?
I think there are multiple points of that. Like first of all is what type of a source data do you have in there? So like if they are in structured field where we just talk numbers, most likely it's going to be just machine learning. If we would be talking, for example, about revenue forecasting, that's not generative AI use case in general. Like all the heavy lifting is going to be done by classical statistics, by classical machine learning. However, if you go to personification where you have unstructured data like text, like comments, descriptions, and
Reviews.
so on. Yes, reviews, exactly. That's where generative AI is coming. In general, NLP field, natural language processing field, is coming in hand where you check like sentiment analysis, extraction of key entities. So that's already where NLP is coming. And if on top of that, you want to have like an interface with the user in natural language, exactly how Andrew has said, that's where generative AI is coming to understand what the user wants, try to map it to some internal comments like to database or like whatever, and to give an answer. Same what we've done on multiple projects is where you have a classical ML under the hood, but the final response is actually like generative AI, because
Exactly.
it's like it's just user friendly. It's like it's a great interface with the user.
Right. So in the review case, like 5 years ago, we would have a client come to us and say, "Can you predict the next product that I would like to sell? Can you predict what customer is going to pick up this new product that I want to advertise? Can you predict the pricing?" I have a cannabis company that's talking to me about trying to do dynamic pricing for cannabis, right? And they would come to us, and the machine learning engineer would sit down with the database and say, "These signals, these anomalies tell me that this product is a good one to put on your shelf." But with generative AI, we can figure out, what did the customer say? How did they review it? What was the response they had? Maybe movements they had across the site can be like dictated inside of a Google Analytics sentiment analysis of like bouncing back and forth between these sites has this context on the website. Therefore, they're interested in this type of cannabis, or this type of feeling they want to have by taking cannabis, right? So that sentiment analysis, when you inject it into a machine learning model in 2025, what is the output that is so revolutionary that it's changing businesses? Like where do you see, like, predict the future, Vitalijus? Like, why is this so revolutionary that no one's thinking about adding ML to Gen AI on Twitter because they're just vibe coding? Like, why is it so revolutionary that you need to do it the right way?
I think it's about flexibility of data. If we would be checking like how the data shifts right now, like we're doubling, I don't know how frequently, but we're doubling the amount of data that's added to the internet like every like 6 months or something. But the point is that most of the data is unstructured. So we have very limited, and that's in general. If we would go like more technically, that was the revolution with models like GPT, or like the first one from BERT, like transformers models. That was like the revolution from there, is that systems are pre-trained on vast amount of data, and then you don't need to teach it too much like for your specific use case. And that's the biggest revolution of generative AI, I would say, because like previously, if you want to create a system to do anything for you, you have to teach it like from the beginning. You need to have like a huge data set, and the problem is that in a lot of use cases you just don't have it, like you just don't have a data. But with generative AI, first model, if we would be talking like late 2018, like Google created this like the system which was called BERT, and it was using like it was used in Google search, if I recall it correctly. Everything what it was taught on was just like just Wikipedia, just English Wikipedia, like I don't know, like 60 gigabytes. And the cool part is that if you would like to make a chatbot, you don't need to teach it English anymore. You just need to learn like your specific topics. But like in general, it knows how to talk because it was taught on the Wikipedia. And right now, like 2025, we have GPT for 103 models, but the principle is the same. And that's where the future is coming. That like before, even 2019, it was a preprocessed Wikipedia data. What happens is right now that newest models, Llama, Gemini, they're going all across the internet. Books, web searches, probably even like Google foundations and like and everything. And this is not data that was manually labeled, and like it's learning from it. And that's the future, because it's really, we constantly create more and more data, and like it's able to learn. We don't go like through classical approach where you spend a month preparing the data set, then you teach the model, then you see like what happens, then you like try to gather more data. We're getting to that point. We're not there yet for sure, but we're getting to that point where models would be able to adaptively learn from multiple sources. Just like imagine a system that could learn continuously from the YouTube, like insane. Like there is like thousands of hours of human interactions uploaded like every day. So before, you would have to manually label it, and it would be like a very, very costly like process. But if you can adapt it, then literally it brings like, it drops all the limits for like from the machine learning and what the machines are capable of.
Now, is this still Gen AI? This consumption of the information that's happening in real time, is that Gen AI?
Well, yes, because like generative AI is mostly working with unstructured data. So like images, text. So that's mostly applicable to this domain.
That's a breakthrough for me because I normally think of generative AI as generating new things. Like, I don't know how they trained the model. I don't really care. I just know I can create an image and clone myself and write some copy. But you're telling me that Gen AI is also the consumption of information that is using new technology that we didn't have available previously.
Absolutely.
Wow. And I wanted to also ask a quick question. You mentioned models. I got invited to a training recently where it was like how to create your own custom model. And I feel like there's these terms fine tuning, creating a custom model. Can you tell me what's the difference here? Like how do I know if I'm building a custom model, I'm fine tuning, or if I'm just using an existing one?
Yeah, absolutely. This is a very good question. So in general, if we would be talking about machine learning like in systems like in general, usually this is artificial neural network that you train. So basically you give set of inputs, you give it set of outputs, and like inside of it, it tries to build such formulas that given an output A, I would give an output B. And that's basically all the magic like behind the machine learning. It doesn't matter, is it GPT or is it like something from before? That's basically what is happening. So initially, if you're building the model, there are existing solutions as for example, and that was what I was telling before as like BERT and other systems. The point is that this is architecture which was already pre-trained for you on huge scale of data, on like gigabytes, sometimes terabytes of textual data, and you don't need to do this. It's already trained enough. And what is called the fine tuning is that the main part of the model is frozen, but you can add some extra layers, or there are some adaptive layers that you can teach it only on your specific subset. So like it still holds all the knowledge, all the general knowledge that it had from before, but you can teach it on some small subset, for example, in medical domain, which was not available during the pre-training. And that's, for example, what happens with OpenAI models when you do the fine tuning. So there is a core which is frozen. It was taught on terabytes of data, which regular business it's impossible to work on such a scale. But you can reuse all of that, and you just train like some few adaptive layers like on the top, like to add to your extra knowledge. Maybe some frequently asked questions like in your business, or like some very niche domain which only you have internal knowledge about. And that's called the fine tuning. The difference with classical ML, what we had before, is that we didn't have pre-training. You create an architecture and you have to teach like from the scratch, and you really go from accuracy zero up to the point, and that's costly. That's like usually costly and sometimes not even possible.
2 years ago, Vitalijus, we worked on our first RAG project before they had defined it as RAG. We didn't know that there was a definition behind it, but we built consumer reports in that way. You were a large part of that project too. It was an awesome success story that we've had at 923 here. RAG is this prompt injection concept of you're taking a bunch of knowledge, injecting it into the prompt using software engineering for the most part, injecting it into the prompt and then saying, hey, large language model, here's some information you didn't know about. You now know about this. Use this in your answer to see if it's important or not. What is the difference between RAG and fine tuning?
That's a good question. Like that's two very popular things right now. So the difference is that fine tuning, it's you teach it on some specific examples. If you have a preset of your frequently asked questions, this is a very good use case for the fine tuning because these things don't change. As for the RAG, this is a more dynamic thing. This is actually a combination of generative AI. It can be with classical ML, it can be with software engineering, but that's where you give to LLM access to some tools or some external knowledge. That's what we've done on the consumer reports, because LLMs have been pre-trained, like for example, a few years ago. It can't physically know that today is, I don't know, like July 2024, or it doesn't know what kind of the weather are there. It doesn't have like an access to the web or something. So the current ChatGPT, for example, this is a classical RAG. It's an LLM which has an access to the tool. So you have, again, an LLM as an interface. It gets the request from the user. and it tries to determine whether it has an access to the tool which can help it to answer the question. Because like originally it can't tell you what the time is right now, but if it has an access to the tool, which is pure software engineering, which just returns you like your system time, it's like, okay, I need to call that tool. It calls the tool. From the tool it gets like the current time, and then it responds like to the user. And something like that we've built for consumer reports, but of course like on way more sophisticated level.
Whereas fine tuning is what? Fine tuning is
Basically if I give you such an input, please give me such an output. So if you have a very specific question that, for example, from general knowledge, it is answering not in the way that you would like to, instead of providing it every time in your prompt, for example, like with a classical RAG, you just teach model like on the architectural level to answer like that. So it reserves you some resources in the future, because if I have frequently asked questions that I want system to answer about, you can do it, you can fine tune it once, or you can add it every time to the prompt. And that's like expensive if you add like such a context, like every time the user is asking the question. Like instead of that, you can, but in a lot of use cases, those two are interchangeable.
right. I have this. I haven't said this out loud. I've thought about this a lot. Fine tuning's kind of like raising a son, where you're like giving the rules and the morals and the guidance of like, this is how you should behave in the world. And rags are like having them read everything they say. Well, you give them a piece of paper and you're like, I'm gonna ask you a question. Here's the answer. Tell me the answer now, right? Like that is that a good comparison?
Yeah,
Yeah.
exactly.
I love that. Great. I think this is a really good starting point for people who are getting into ML, understanding Gen AI. And that's what we're here to do, is to give you guys practical education on the space rather than just saying, hey, buy this thing, do this thing, let you actually get the education. So one of my final questions for you, Vitalijus, is understanding someone who's non-technical. What's the like minimum, that like Pareto's principle, that 20% that they probably need to at least understand to be able to make a decision about whether it's hiring someone on their team, hiring a vendor like 923 to build a custom solution, or even deciding which model they're going to use to prompt their latest piece of content?
I think very important thing is whether you have in-house knowledge how to build things, and how important is optimization for you, because you can build most of the use cases relatively quick, but it's going to come at the cost of like latency optimization, accuracy drift. So if you just need some quick demo to show on presentation, that's one thing. But if you need to support it afterwards, you need professionals who understand how the things are working and what are the pitfalls. Because we had a lot of use cases where companies were coming to us, they tried to build something, first results were like amazing, and then like 2 years in progress and they're still like at the same point, and then we're checking what's in there, and we have to build from the scratch, because just like initial concepts were just strong. So it's with all the transition in machine learning, there is a risk, because it sounds very easy. And indeed, like to try right now machine learning, it's way easier than it was before. It's like plug and play, vibe coding, a lot of like pre-trained models. But production, especially in generative AI, it's like in some parts it's even harder than like in classical ML. And like you don't feel it like from business perspective. You feel like it's like pam pam, good to go to production. But it's like you can make a lot of expensive mistakes because it's not deterministic, and this is such an output where it's very hard to notice that there is a problem. So like imagine if you have a clear like classical prediction, you can very clearly see that your system is not working, or that it's out of like your accuracy. But if it's a chat bot for like thousands or millions of users, like if in some specific chats it starts hurting your brand, you're not going to notice it, because like in general it's working, it's responding like in your 100 test cases. But on the scale, that's where you need people who have built something like that before, or you can get lucky up to some point, up to some scale you can get lucky, but like sooner or later it's going to catch up on you.
I vibe coded and I just bang my head against the wall after like 8 hours of this. I just come to Vitalijus and I'm like, can we build a database with an actual deterministic output? Because I'm done. Like I just circled around. It's a waste. It's a waste when you're trying to do something legitimate. Like we don't have a CFO, so we're trying to get our financial stuff into a Gen AI so that we can ask our CFO questions. That's our goal. But I can't do this without a developer. Like I've given up.
I think there was something you said a while back where you're like, vibe coding is perfect for these single use case tools. Like, hey, I built a vibe coded tool that helps me track my money, and like that's perfect. Like you are a person on your own doing whatever. You built something to track your gym workouts, that's fine. But when it comes to a production release, you do not want to put that in the hands of real customers.
No. You know what I think is so sexy about it is everyone wanted to be an engineer and they were jealous of engineers' ability to create like really cool things, like companies or SaaS companies. And then they got the vibe coding thing and they're like, cool, now I can be an engineer. It's like giving someone a pencil and being like, now you're an artist, right? And they like a little kid can draw a picture of anything. It's not great, but like they can draw just like vibe coding. You can engineer, but it's not going to be something that people will use.
It's like lottery. Everyone wants to be rich and like to have it like very easily. So like it's literally the same. And like one very interesting point, especially for the vibe coding, it works more or less in some use cases when you work with older technologies. Like one very interesting insight, if you would like to work, for example, with RAG or with some LLMs, it's so bad. Like if you're gonna ask like ChatGPT like to work with the newest technologies which came up like in the last like year, for example, it's even more unreliable than working with the old because it has been fine-tuned by actual teams on some very specific coding tasks. That's why, for example, if a new LLM can code you chess or snake like faster than the previous one, it doesn't mean that it is intelligent. It just has been like fine-tuned on some specific use case which was there like for 30 years. Ask it to work like on a new library, and that's where it starts to hallucinate insanely, because we even internally when we hire like in our ML team, like one of our layers is a coding
Test challenge.
test. Yeah. And every interview I'm telling like you can use whatever you like. If you want to use ChatGPT, I don't care, just solve the problem. But the thing is that our tasks include working with the newest libraries, and when they start vibe coding, not a single person so far has passed testing code like with vibe coding from us. And something super basic, which like if you know what to do, you can do it like in 10 minutes. I have seen like we try to avoid it right now, but I have seen people banging their heads like for 1 hour in one liner just because they tried to vibe code it. It threw an error, then they tried to, and it gets, like this. Not a single person.
Wow, that is insane. This is so good. I feel like we need to have another follow-up on this where we kind of answer some of the common questions about ML. But I think this really gives someone a great starting point to have some clear definitions and what vibe coding is good for and what not. But we probably need a whole episode on just vibe coding. 100%. We'll put a pin in that. All right, that concludes this episode. If you like this video, then you'd like our episode from last week if you haven't seen it, where we go into some of the most common enterprise AI mistakes. And then also, if you're looking for new information, get on our newsletter where we're sending out nuggets like this every 2 weeks and keeping you on the pulse of what's happening in AI. All right, thanks, Vitalijus. And thanks, Andrew.
Thank you.
Thank you.